Okay, welcome back to another video. Okay, this time for our 3-unit level, we're looking at methods of integration. Just before we start, there's my email. It's draussiemaths@gmail.com. Okay, so you can contact me there on any problems that you have with any videos. Okay, if you're after any type of tutoring, okay, I'm located in the Sydney area. Okay, or anything you want to chat about, so you can contact me through that email. Okay, so what are we looking at today? Methods of integration. Okay, here's some notes. Okay, this is just the note part explaining what we're going to be looking at with the harder questions and examples in the following videos. So, primitives of sine squared x and cos squared x. Okay, so how do we integrate sine squared x and cos squared x? So this is at 3-unit level. Okay, now known as Mathematics Extension 1. Okay, so both are integrated using the double angle formula. Okay, we've learned that in our 2-unit days. So we know that cos 2x is 2 cos squared x minus 1. So if we solve for cos squared x, this is what we get. Okay, I'm sure you guys can make cos squared x the subject here. And same thing for cos 2x, we get 1 minus 2 sine squared x. Okay, so they're both the same. And if we solve for sine squared x, this is what we get. Okay, there is a video on all my trig identities and how we obtain them all. Okay, so if you're not sure about this trig identity, okay, you can watch that video there. So the example that we're going to do, okay, and I've done it here for you. Okay, I've already answered it because we're going to look at harder examples. We're going to do them together. We want to integrate cos squared x dx and sine squared x dx. So if we make that substitution, okay, integral of cos squared x, okay, well cos squared x is half 1 plus cos 2x, so that's what we're integrating. Okay, so you have to make that substitution. We can take out the constant, integral of 1 is x, and to integrate cos 2x is half sine 2x plus c, and if you expand that, you end up getting half x plus 1 over 4 sine 2x plus c. Okay, so that's the integral of cos squared x. Okay, that's its primitive function. Same thing with sine squared x. So I just sort of squeezed it in there. Okay, sine squared x is half 1 minus cos 2x. If you take out the half, you're left with 1 minus cos 2x dx. Integral of 1 is x. Integral of minus cos 2x is minus half sine 2x plus c. You expand it, you get similar answer, just the only difference is one's a plus, one's a minus. Okay, so there are primitive functions for cos squared x and sine squared x, and we're going to need to use these for the next few examples, which are going to be a lot harder.